Okay, this time we're going to have a look at our new y variable. So new y is constructed as being a function of x1 and new x2. It's got the exact same formula as y did with x1 and x2, but now we've got the difference that x1 and new x2 are correlated with one another. Let's take a look at a scatter plot to verify that. So data x1 and new x2. What we should see is that these two are not independent of one another, but instead knowing something about x1 tells us something about x2, or vice versa, knowing something about x2 tells us something about x1. So that's the key difference in this part of the data. Is that if we were to leave out x2, x1 already tells us a lot about x2. x1 already contains a lot of the information in x2. So leaving out x2 is not going to be as much of a disaster for prediction as it was before, but we're going to misestimate the relationship between x1 and y. Okay, so let's do our regression here, analyze regression, HP linear regression, again for speed. New y is our dependent variable, x1, new x2 are explanatory variables, effects, add in both x1 and x2, add and run. We should get another really good model to start off with, because we know that we do have the true model for x1 and new x2 estimating y here, and indeed we do get a really good model, root mean squared error 10.3, that's right there, r squared almost 99%, 98.99, looks like that would round up to 99%, and beta 1 and beta 2 are again really close to the true values, 30.42, and 19.67, real close to the actual values of 30 and 20. Okay, so let's modify this now and leave out x2, of course incorrectly, because we know that x2 is truly part of this model. Hit run. We're going to get an r squared that is not nearly so disastrously bad as it was before. By leaving out x2 previously, our r squared fell down to 48%. This time it only fell down to 90.4%, 0.905. Our root mean squared error rose to only 31.6, so it's only about 3 times as bad as if we include x2, rather than 6 times as bad, like in the first set of data. Let's see. So our parameter estimate for beta 1, and this one you can see is a disaster. So this one is just completely wrong now. We are completely misestimating beta 1. If we really cared about learning what the true relationship was between x1 and y, by leaving out x2, we've messed ourselves up completely now. However, if we were just interested in prediction, these guys over here, the r squared, the root mean squared error, tell us we're not nearly so bad off. We're still going to be able to estimate things relatively correctly, relatively accurately. We're going to get the exact same results, or the same style of results, rather, if we leave out x2, leave out x1 instead of x2. So let's do that. Add x2 back in. Hit run. We should see the same sort of results. Our r squared is now 0.86, 864. Our root mean squared error 37.82, and our beta 2 38.56. So again, we've got the same sort of results, that our parameter estimate beta 2 is completely messed up when we leave out x1, which was correlated with x2 or new x2, but our estimation is not as bad as it was when we left out the uncorrelated x1.